All right, this is the pre-video from section 2.6, Inequalities. So we're looking at solving linear inequalities and graphing solutions and writing them in interval notation. Those are our objectives. To start out, we need to make sure we understand what an inequality is. It's a statement that two quantities or expressions are, not equal to each other. Sometimes it's less than or equal to, greater than or equal to. Sometimes they even just say not equal to. This symbol right here is actually also considered to be an inequality because it's just not equal to. It's not the ones we're going to be using in this section. We're going to be focused on the less thans and the greater than. Make sure you understand the difference between less than and greater than. A lot of people learn the fish, the alligator eats the larger fish. But you need to be able to read it from left to right. So the point coming first means you read that as less than. The opening coming first you read as greater than. So if we consider the inequality 2x plus 3 is greater than 11, where x is a variable, there's an illustrated table here below that shows how you could just kind of plug some numbers in and see if the statement comes out true or false. For example, if you plug in 3 on the left side, that's 2 times 3 is 6 plus 3 is 9. 9 is not greater than 11, so that's a false statement. If we plug in 4, then we get 8 plus 3, which is 11. Greater than 11, that's not true either because you do not have the equal to symbol. So when we plug in 5 and 6, we see that those both make true statements. The problem is that we don't really know if 5 is the first time that becomes a true statement or not. There's probably some fractions or something in between 4 and 5 where it switches from false to true. But the thing to note is that in an inequality, any number that makes your inequality true is a solution to the inequality. So there's not going to be one single solution. There's going to be a group. In fact, it's going to be usually an infinite group because it's going to be a lot of numbers that make the solution true. So to solve means to find all the solutions. And we know that two inequalities are equivalent if they have exactly the same solutions. This is something called a compound inequality. For example, this says that 2 is less than x, but x is also less than 5. This means every number between 2 and 5, but not including those endpoints. So we call that an open interval, and we denote it by 2 to 5. This is called interval notation. Interval notation means that you tell someone the starting value of what you would be giving your solutions, and then the ending value. And we're so pretty much talking about if you shade it between 2 and 5. So here's 2, here's 5. Most of you will remember that if you don't have an equal to, you use an open circle. Open circle relates to parentheses. Closed circle is going to relate to something called a bracket that we're going to use in a minute. So this is not an ordered pair. This says every number between 2 and 5, but not including 2 and 5. So that graph is there. You can see that. And that's called sketching it. So we put our endpoints with either a parentheses or a bracket, depending on if it's including the number or not on those endpoints. And then we shade the appropriate solution set. If we call that equal to, so 2 is less than or equal to x or less than or equal to 5, notice we change that to a bracket to indicate that we are including those numbers. And that's called a closed interval. You can also have half open or half closed interval. We always call them half open, but you could also call it half closed. That's when you have one endpoint that's included, but the other one is not, and that could go either direction. And then we have something called infinite intervals, which is what we have is when you have infinity. So we're going to be shading to forever to the right, or we could be shading to negative infinity. So this chart right here, and it's hard for me to keep it on this with the tablet, but this goes through all the different possibilities of how you could look in interval notation. What does that look like as an inequality, and what does that look like as a graph? So notice an open interval between A and B, closed interval between A and B, half open, half closed, with A being the closed part, half open, half closed, with B being the closed part. This is from A to infinity, so notice it goes all the way to the right. Closed, that means including A, to positive infinity. Notice that when you're negative infinity, you have to list that first, because when we list our interval notation, you always list from smallest to largest, so from left to right. So negative infinity to b, negative infinity to b including, and then if you ever shade the whole number line, that's negative infinity to infinity. Something to note is that we never, ever, ever use a bracket on infinity. Brackets are for when you have a closed endpoint. Infinity is not an endpoint, it's a concept of going on forever. So that never gets a closed interval, it's always just the parentheses. All right, so let's talk about some notation. We're going to express the inequalities as an interval notation, and we're going to sketch the graph. So x is less than or equal to 5. So I usually do the graph first because the interval follows pretty closely from that. And you don't have to be perfect with these, just put the number on the number line. This is equal to, so that's going to be a bracket, and x is less than, so we're going to be shading to the left. So that's everything that is less than or equal to 5. As interval notation, that would be negative infinity up to 5 with a bracket on the 5. Okay, let's look at the next one. X is greater than negative 3. So imagine on the number line where negative 3 would be. This is not equal to, so we're going to be using a parentheses, and it's x is greater than, so we're going to be shading to the right. You always try to open up your parentheses or your bracket to the direction that you're shading. So that would be negative 3 to positive infinity. Okay, this next one is a x is between two numbers, so that means that you're not going to the infinities. You're going to have two endpoints. So this time I do put a little bit more details on my number line since there's more than one number. So negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. So we have a bracket on the negative 3 because it has the equal to. We have a parentheses on the 5, and x is in between. Not beyond it, though. So this would be negative 3 with a bracket, up to 5 with a parentheses. Okay, let's look at this one. This is negative 3 to negative 1. So negative 3, negative 2, negative 1. Parentheses on both, and x is in between again, so we shade everything in the middle. So this is negative 3 to negative 1. And then this last one's kind of a trick question because this is not written in increasing order. You always want this to be smaller than the number over here. So that means we need to flip this whole thing because negative 5 is actually smaller than negative 3. So negative 5 is less than x, which is less than or equal to negative 3. You flip everything, the two numbers and the directions of the inequalities. You do still keep the equal to closer to the negative 3 like it originally was. So this would be negative 5, negative 4, negative 3. We want a bracket on the negative 3, a parentheses on the negative 5, and we're still shading in the middle. So this is parentheses negative 5 to negative 3 bracket. Okay, the next group is, here's the interval notation. Write this as an inequality. So these we're not graphing, we're just writing them. So remember, this is your starting, this is your ending, and notice there's no infinity. That means x is stuck in between. So think about 0, an x, and a 4. And it always, when you have this in the correct order, it's always less than, because you're saying this is smaller than this, and this is smaller than this. So this would be less than or equal to because of the bracket, and less than. For the next one, it's between 3 and 7, so 3 and x and 7, and they're both going to be just less thans. And then for the next one, we're saying negative 3 to positive infinity, so we're going greater than that. And notice there is an infinity, so that means you should only have one inequality. So x is greater than negative 3, but not equal to. And then finally, this is looking like we're shading to negative infinity, so to the left. So this would be x is less than or equal to positive 2. And it's less than or equal to because of the bracket. All right, so that's it for those parts. So the very last thing that's on this free video is just we're going to solve a few of these before we get to class. So methods for solving inequalities in X are similar to those that are used for solving equations. In particular, we often use properties of inequalities to replace a given inequality with a list of equivalent inequalities. In other words, adding something to both sides, multiplying or dividing or subtracting. So you can add things to both sides or subtract to both sides, and that is completely legal. When you multiply or divide, you have to be careful. If you multiply or divide by a negative number, that changes the order of the numbers, because think about having 2 is less than 3. That is a true statement. If you multiply this by a -1 on both sides, that makes this -2 and -3. -2 is not less than -3. Actually, -3 is smaller. So if you multiply or divide by a negative number, you have to flip the direction of your inequality. So that's this next statement. If you multiply or divide both sides by a negative, you must reverse the inequality sign. Compound inequalities, we're not really going to do much with this. We'll see it maybe once or twice. But and or, that comes up, it actually comes up in class when we do absolute value inequalities. Because if you have an and statement, you're talking about the intersection or what two inequalities have in common. So imagine graphing both inequalities and only looking at where their shading parts overlap. An or is a union. If you have two inequalities separated by the word or, you are looking at what they both have. So either set, if that part is shaded, it's part of the final answer. So that's called a union. All right, so if you're trying to solve a compound inequality, you're going to try to get the x by itself, or if it's if you have one where you have two inequality symbols, you want x in the middle by itself. So let's look at this very first one. And our answer has to be written as interval notation according to the directions. So this looks sort of like the equations we were solving back in Unit 1. It looks like it has an LCD of 12. So I'm going to try to multiply both sides or everything by 12. So 12 divided by 4 would be 3x. 12 times 7 would be 84. Less than or equal to 12 divided by 3 would be 4x. 12 times -2 is -24. I would subtract the 3x over, so that's going to be x minus 24. Add the 24 over, that's going to be 108. Now, before you go trying to graph this or write it in interval notation, I would flip it. When you do graphing or interval notation, it is always best if the x is on the left side so that you can read it correctly. Because most of the time people just look at this symbol and just, say, I'm going to shade the direction that's going. That seems to work most of the time. But it's not true if x is on the right side. So x and 108 are switching spots, which means we need to make sure this opens to the correct value. So we're going to make sure it still opens to x. So this is actually read as x is greater than or equal to 108. So if we graphed that, just so you can kind of get a picture of what it's going to look like, that would be bracket and then shade to the right. So interval notation is 108 to positive infinity. Okay. Then let's look at, I think this is the last one I have on the pre-video. Yep, this is a compound inequality. We'll do probably 2 or 3 more of these in class together. But when you have a compound inequality, your goal is to get x by itself in the middle here. So I'm still going to multiply everything by that LCD in the middle. So I'm going to multiply everything by 3. So that's going to be -6 is less than. Now when you get to this part, the 3 and the 3 cancel, so you just get the 4x plus 1. You do not distribute that 3 to it. And then less than or equal to 0 times 3 is still 0. We would subtract 1 to get this x by itself, but whatever you do to the middle, you have to do to the other two sides, because you really almost have like 2 equal signs. So this is -7 less than 4x less than or equal to -1, because that's subtraction. And then divide everything by 4. Now notice, I didn't flip any directions of any inequalities. I never multiplied or divided by a negative number. I subtracted, but that's not multiplication or division. So I'm getting anything between -7/4 up to -1/4 with a closed interval on the -1/4. So that's going to be parentheses -7/4, comma -1/4 bracket. Okay, and that's it for the pre-video.